All right, what we're looking at today is the measures of center and spread. Measures of center are the mean and the median. So to find the mean and the median, let's take a look at the following example. We're looking at this list of data, which is the April high temperatures in degrees Fahrenheit for 5 consecutive years in Boston. Find the mean and the median, which again are our measures of center, and then it asks you to find the range and the interquartile range for this data set, which we'll talk about later because those are the measures of spread. The measures of center, the mean, another word for mean is the average. To find the average or the mean, you take all of the numbers that are there and you add them together. So I added 77 plus 86 plus 84 plus 93 plus 90. And then you divide that by how many numbers that there are in your data set. So we added 5 numbers, so we're dividing 430 by 5, which gives you a mean or an average temperature of 86 degrees. To find the median, you have to put the data in order first, from least to greatest. So our data is in order: 77, 84, 86, 90, and 93. To identify the median, you have to cross off the numbers as you go, one from each side, until you get to the number that is in the middle. So I'd first cross off one from the left and one from the right, one from the left, one from the right. That leaves the number 86 in the middle. So then that would mean our median temperature would be 86 degrees. Now, sometimes you have an even number of numbers. So let's say we had 77, 84, 85, 86, 90, and 93 as our numbers. To find the median, you'd still have to take off one from each side until you get to the middle. So we'd have to take off 77 and 93, 84 and 90. But now if you notice, we have two numbers in the middle. We have 85 and 86. So to figure out what the actual median is, you have to take those two numbers and add them together. So we have 85 plus 86. So if we add 6 plus 5 is 11, 8 plus 8 is 16, plus the 1 we carried is 17. So I have 171. The reason we're adding them together is because we're finding the average or the mean number that's in the middle. So remember, to find the mean or the average, you have to add the numbers and then divide by how many numbers you added. So we just added two numbers together. So I want to take 171 and divide it by 2. 2 doesn't go into 1, but 2 goes into 17 8 times, because 2 times 8 is 16. We subtract and we get 1. Then I bring down my other one. 2 goes into 11 5 times, because that gives me 10. I subtract and I get 1. So I have 1 left. I'm not done. So that means I have to add a number here and I have to add a 0 there. So I have 10, and 2 goes into 10 5 times. Minus the 10 gives me 0. So my median here would be 85.5 degrees. So if you have two numbers that are your median, when you find in the middle, you cannot have a median with two numbers, so you have to find the mean or the average of those two numbers. The next thing we're talking about now is the measure of spread, or basically how far your data are from each other. So the first measure of spread you're probably familiar with is the range. To find the range, we take the maximum and we subtract the minimum value from it. So our maximum in our data list that was on the previous page was 93 degrees. Our minimum was 77 degrees. To find the range, we subtract 93 minus 77, which gives me 16 degrees. The interquartile range, however, is a tad bit different. The interquartile range is the range that has to do with box and whisker plots, which we will talk about further when we get along in this course. But to find box and whisker plots, or to find the interquartile range from a box and whisker plot, you have to find the first and the third quartiles. As it shows you on your screen, the quartiles are the medians of each half of data. So, if you recall, we found the median was 86 because we took each side and we crossed off 1 until we found the number that was in the center. So the first quartile, you take all the data that's beyond the median in the lower end and you find the median of that. So if we're looking at that aspect of it, there's only two numbers. There's not one that's in the middle. So that's just like on the previous page where we talked about it. We have to find the average or the mean of those two numbers. So I would have taken 77 and 84 and added them together, which gives me 161. Then I would have divided it by 2 because that was how many numbers I added. I did the same thing on the other side. I would have added the numbers that are here on the high side, divided them by 2 because there are only 2 of them, and then I would have gotten 91.5 degrees. Now, however, if there was a number that was in the middle, say I had 90, 91, and 93, okay? If I found, those are my upper data, I found the median is 91. There's no need to add or divide because I already know what the median is of the upper half of data. So my third quartile, if that was the case, would just be 91 degrees. However, again, because we only have 2 pieces of data above and 2 pieces of data below, there is no number in the middle, so we had to find the mean or the average of each section to get the values for the quartile. Once you have the values for the lower and the upper quartile, or quartile 1 and quartile 3, to find the interquartile range, it's very similar to the actual range. You just have to subtract the maximum value, which in this case would be the quartile 3 or the upper quartile, from the lower quartile or quartile 1. So my quartile 3 is 91.5 and my quartile 1 is 80.5. So I'm doing the subtraction, which is 91.5 minus 80.5, which gives me an 11. So the interquartile range is 11. The next measure of spread that we are going to look at is standard deviation. Standard deviation is a measure of how far the data is spread apart from each other. Basically, if you have a large standard deviation, it means your numbers are very far spread apart from each other, or you have a few that are very far apart from the rest. If you have a small standard deviation, it means your numbers are very much close together. So there are 5 steps in calculating the standard deviation. In calculating the standard deviation, the first step is to calculate the mean, which is the x with the bar on top. So we already calculated the mean. The mean of this value was 86 degrees. The next thing is to calculate each value's deviation from the mean. So deviation just means how far it is from the actual mean. So you take the value and you subtract the mean to figure out how far each data piece is from the mean. Step 3 is that you take your differences that you just found and you square them. Step 4 is you find the mean of your squared deviations, which means you take your squares that you just did and you add them together and divide by how many you added, because remember, that's how you find a mean. Then you take the square root of each mean of the standard deviations, which should and more than likely give you a decimal answer, which we'll talk about more again on the next page. So remember, the mean is 86. So we have each piece of our data value listed in the table. I have 77, 86, 84, 93, and 90. So the first step after we found the mean is to find the deviation, or basically how far it is from the mean. So if you recall, I have my mean of 86. So I'm taking my values and I'm subtracting the mean from them to figure out how far they are from the mean. So if I'm looking at that, I have 77 minus 86 equals negative 9. 86 minus 86 equals 0, and so on. The next step was to square the deviations. So I took the deviations, or this subtraction problem, and squared them. So the first one, negative 9. Notice negative 9 squared. Remember, squared means to multiply the number by itself. So negative 9 times negative 9 is not negative 81. Remember, a negative times a negative is a positive number. Then, after I find the square deviation, I have to add all my square deviations together. So I'm adding 81 plus 0 plus 4 plus 49 plus 16. I add them together, I get 150. I added 5 numbers, so to find the mean or the average, remember, we are dividing that number by how many numbers we added. So I'm dividing 150 by 5, which gives me 30. My last step is to take the square root of the mean we just found. So I take a calculator and I find the square root of 30, which is approximately 5.47. For what we're doing for now, we're rounding our standard deviation to the nearest tenth. So I would have 5 and 5/10. So my standard deviation for that data is 5 and 5/10.